And it looks we're live. So good to have you. Welcome to the first of you that have already joined. Hey, Florian. Hey, Andre. Hey, Andre. Hey, Lawrence. Hey, Taras. Hey, Vamsi. Nice to have you. We are looking forward to this session today. We are going to cover managing Kubernetes app configurations in growing teams. And we are doing so in a little interview format style between myself and Chris Stevenson, who is Kubernetes CTO and has spent a good amount of time thinking about those things at companies such as Google and obviously Humanitech and many others. And we're very much looking forward to the session. We will wait a couple of more minutes before we actually start this entirely, and so that a few more people can join. You can post questions anytime here in the chat window on the right hand side. And some of you have already handed in their question before this meeting. Thank you very much. We are also going to cover those in the course of the conversation. And again, if you have any questions in the meantime, feel free to add them. Hey, Zuza, good to have you here. It's great to see that we also have many people that join several of our webinars. That's always great. I'm missing Costas, who is our most loyal attendee, attending every single one of our webinars so far. Let's see whether Costas also joins. And again, we're going to give it one more minute, and then we are going to start. Hey, Valentin from Romania, I believe. We've been working together several years back, I suppose. That must have been 2014, 15. Great to have you here. Maybe not a great fit for the session, but do you have proven ways to apply different resource limits for the same app in different environments? That is a great question, Lawrence. We'll see whether we get to that in the course of that conversation. And again, feel free to put in your questions at any point in time. And I think with that, we are now starting this conversation. So again, welcome everyone to this webinar around managing Kubernetes app configurations in growing teams. We are going to keep that very interactive and hopefully as brief and vivid as possible. And with me is Chris, and Chris is Humanitech CTO and has been building internal developer platforms and has been dealing with a lot of application configurations throughout his career. So thank you, Chris, for being here with us today, and thank you for taking the time. And maybe let's just kick this off with giving us a brief idea on what we're going to talk about today. And that is threefold. We are first going to go through evolutionary steps. So I think in the life cycle of every team and every applications, there are certain things you go through, certain technologies you use, certain methodologies you apply when you are dealing with application configurations. We're going to cover those really quickly to see so that you can find yourself in that journey and understand how to get from methodology one to the next step. We are then going to have a look at how this affects the different personas in a team. That is very important, like the person that is dealing with the infrastructure or the DevOps side of things or the application developer, and how to make sure you orchestrate that and find the right approach, the right architecture for the right team setup. And then the last thing is choosing the right horse for the right course. So how do you actually define what approach, what methodology is the right thing for you? And then we can have a Q&A and answer a couple of your questions, and I'll have a look at your questions that you post along the way, and we'll try to also cover those during the conversation. Now, Chris, let's briefly start to define what we actually mean if we talk about application configuration management, so that we're all on the same page?
Yeah, so thank you very much, Caspar. So kicking off with application configuration management, I would say it's a few things. So the most obvious being anything that lives in a config file or is pushed into your application via environment variables. So classic examples of this are things like database connection strings or ports that your application is listening on and so on. So those are kind of obvious bits. Especially in the Kubernetes environment, application configuration goes a bit further because it also talks about how your application is structured to a certain extent. So for example, when you define your pod, what sidecars are required for your application to work correctly. It may be that you have a dependency on a sidecar to do something like log processing, or maybe even to connect via a sidecar to a database, such as with the Google Cloud SQL proxy. So application configuration is what you inject into your application via configuration files and environmental configurations, but it's also how your application is built. That is what code version you have, what components are there, what dependencies does it have, as in sidecars, and maybe even what dependencies it has in other pods or managed services that live outside of the little bubble that your application is running in. It's probably also worth talking about things that are not part of application configuration to make the comparison. The main thing we're not talking about here is any kind of infrastructure configuration. Mm-hmm. So we're not talking about the VMs you're running on or the version of Kubernetes necessarily that you're running on, or exactly how your database is stood up. Those are things which are part of the infrastructure world, and you can draw a not necessarily clear definition between them, but most of the time you get a good feel about what counts as infrastructure configuration management and what counts as application configuration. For the purposes of this session, we're talking about application configuration.
All right, cool. And with dependencies that the application has, or the resources that the application has, with its outside world, resources can be something like a database, like DNS, like file storage, all that. Is that correct?
Yeah, so from an application configuration perspective, it is where those things are or how to connect to those things. Mm-hmm. And from an infrastructure configuration perspective, it would be how do I set that up? How do I instantiate a database instance? What physical storage is my file stored on?
Awesome, cool. That makes sense. That's in the course of our work, we look at literally hundreds of different Kubernetes setups and the way people deal with configurations. And it's interesting to see that there is a certain pattern of evolution. So every team you see can be basically sorted across different stages. Yeah, let's look at those stages and how you actually define them.
Yeah, so by stages, we're talking about the maturity of approach to dealing with application configuration. And on this diagram, on the left-hand side, we have the most immature, or I guess the initial setup. And on the right-hand side, we have the most mature. So here we're talking mainly large enterprises that have really got this whole system nailed down. And then there's generally a relatively common path through them. So let's start off at the left-hand side with kubectl. I think there's an E missing in the kubectl. Mm-hmm. This is basically the lowest common denominator. So if you want to push something, put some new configuration into your Kubernetes cluster, you throw together some YAML to create these manifests, and then you do kubectl apply, and your cluster is updated, and everyone has a great time. So this is really good for getting started. It's actually a very low barrier to entry because you don't need much in the way of tooling to get this going. You do text editor and kubectl. The problem is that as teams grow, especially as you add more and more people into the mix, it becomes increasingly difficult to keep track of what's going on. Mm-hmm. So I'll give one example. If you are just mutating the state of your cluster effectively, then how do you know what was in the cluster before you pushed a bad manifest. So if you push something that breaks, the next question is, okay, that broke. What was there before? How do I roll back? Kubernetes itself doesn't provide versioning for you out of the box. So you have to either hope that you saved the previous configuration somewhere or that one of your colleagues did. Otherwise, you'll have to figure out kind of by trial and error what change caused the problem that you're now seeing. So that's the kind of first problem. The second problem is when you have multiple people making changes, you have multiple opinions thrown into the mix. That means that you could have multiple ways of doing the same thing. So Kubernetes YAML is both very well defined, but also relatively flexible. So there are multiple ways of achieving the same thing. This is especially true when you start using things like annotations and labels. The strategies you use to label things up can be different between different teams or even different people within a team. And so it's very hard to ensure consistency. So if person A edits, makes an update to your cluster, and then person B makes an update to the cluster, those two things might be in conflict with each other because you both have different ideas about the approach you want to take to define the configuration you want inside Kubernetes. So as soon as you start getting to this situation, teams start trying to find tooling to help them. And the two big options that you find when you start looking for tooling to help are Helm and Kustomize.
Can you maybe two slides?
Oh, sorry. Yep. So I'll just give a moment for people to appreciate the kubectl kangaroo. Yes. So we've got Helm and Kustomize are the two main things there. They're both solving the same problem, but they do it in different ways. And the basic problem is, how do I create standards in how I define my manifests and therefore my application configuration in a way that allows me to make changes in a predictable manner, and also allow this to be scaled across the team without everyone having to figure out what the intent of the setup someone had before. So as I said, they both work in very different ways. So Helm has an approach based on templates, and you could think about it as a very strict abstraction. So you have a template, which is a big chunk of Kubernetes manifest, and then you have a values file, which is all the stuff that you're allowed to twiddle in the template. This is great because there's a very clear interface about what you're allowed to change, and if you don't, in theory, you don't need to understand what's going on in the template in order to make changes. So, for example, adding an environment variable to a config map is usually as simple as adding to an array object in the values file, and you don't have to care where the config map is defined in the template or what its name is or anything like that. Kustomize, which, as I said before, solves a similar problem, has a different approach. It's kind of drawn from the world of object-oriented programming in a way. And basically, it takes an inheritance model. So you take a base, and then you kind of specialize that base over time by effectively providing additional subclasses if you're from the from the object-oriented world, in order to specialize the resulting YAML for the situation you need. So you start with a generic service, and you specialize it by swapping in different images and defining different specialist configuration as you go on. They both work great, but they both have a series of shortcomings. And these are kind of what drives people to the kind of next stage. So the big shortcoming is generally that neither of them is perfect. So if you have a template system, everything is great if you're just manipulating the values file. But all of a sudden, when you make a particular change, you're going to have to update the template itself. And as soon as you update the template, then the values file that you had previously doesn't necessarily match the template, which makes things like rolling back to a previous version tricky, because you now need to version the entire blob, so your template and your values, and updating the values is not sufficient to ensure that you have a full understanding of the state of the application you're deploying. This is especially a problem when you have multiple environments. You can imagine I make an update to my template for dev, but I don't want that update to be applied to staging yet. So I end up with a copy of my template for dev and a copy of my template for staging. and then I have to make these updates in place and so on. And then we end up with a whole versioning and conflicts problem again in this world of templates. So we kind of just push the problem down the path, and then we find the problem again. You have similar problems with Kustomize. Here, the problem is a little bit more kind of complex, but you end up with the same problem that you end up with concept of kind of the brittle base class, which is another common problem with object-oriented programming, where you end up with this fundamental structure of the base, which you can't change anymore because it breaks everything else that it depends on, because there's implicit dependencies all the way down the chain. This, over time, as your structure gets more and more complex, ends up limiting what you can do with Kustomize, and so therefore causes this kind of problem. So variously, people start coming up with strategies, and they generally involve very complicated Git setups in order to try and track the changes between not just the values, the parameters that you care about, but then also the templates or the full stack of Kustomize inheritance that you have.
Yet, if I can interrupt you really quickly, like this is, of all the setups we see, really the predominant method, right? So I think predominantly, if we look at application configuration management in teams that are using Kubernetes, the vast majority is using some sort of Helm chart or customized setup, predominantly, I think, Helm chart. And then actually, as they're growing, and as now more and more teams are maturing into that direction of having worked with Kubernetes for a while now, they're encountering these issues, right? That get if you hit production scale.
Yep.
And we've had an interesting conversation a couple of weeks ago with one of the Helm charts, Helm chart creators around that Helm is ultimately not really designed to solve that problem. It's a way of describing those configurations in a structured way, but it's not really designed for then taking that at large scale and taking that to that next level, right?
Yeah, so I mean, the maintainer was actually pointing out that Helm was always designed as a package manager. Right. So it's how do you package Kubernetes applications, and the template structure makes a lot of sense because you can then have a load of values, and then you can manipulate the values because you are tweaking how the package is set up. But from a development perspective, it doesn't make sense to be running multiple versions of your package and trying to guarantee consistency between them. So that was his point. That point is kind of mute because everyone in the industry pretty much uses Helm as their base way of organizing Kubernetes manifests for application configuration. There's a small but loyal band of people who use Kustomize, but as you said, Caspar, I think they are a minority in comparison to the number of people that have adopted Helm as their attempts to manage Kubernetes manifests to scale.
Yeah, definitely. So let's look at we're taking the next step. We have to deal with those versions. We have to be able to sync those versions into the cluster. What do you? That's where GitOps comes into play, and a lot of heated debates that we've had around this particular approach in the last months, really.
Yeah. So GitOps is really interesting. On paper, it's a great system. It has a load of properties that developers especially and engineers really like. One of which is that by definition, all of your application configuration is represented by a single SHA-1. So a Git commit can describe the state of where your Kubernetes cluster should be, right. Which is great. And it also allows you to do really cool things like separate the generation of your application configuration from the application of your configuration to a cluster. So effectively, a Git repository becomes the method of transporting across a firewall, say from your dev environment to your production environment, without having to have any live network connections between the two. So those are all great properties. And generally what you end up with is people are versioning all of their, for example, their Helm charts. They have created multiple repositories or multiple directories or multiple branches, depending on the strategy they want to take to represent different environments. And they then make various pushes, and there's a load of automation, which will then take what is committed on a particular branch and apply it to a cluster. And then in theory, via some kind of tool like, say, Argo CD, that then gets applied and you have a shiny new version of your application up and running. So this is great in principle. In practice, it often fails to live up to the hype, and we've had a lot of debate around it. The situation here is not anything in theory. In theory, it's great, but as always, in practice is where the problems lie. One of the problems is scaling across multiple environments. If you're creating subdirectories per environment, you then have a manual task of trying to reconcile differences between your environments. Say I have a dev1 directory, a dev2 directory, a QA directory, a staging directory, and a production directory. If I want to move things between environments, I effectively have to read the contents of one directory, diff it with the next one, and make sure that I'm transferring everything across. That's not something that GitOps helps you with. And in fact, Git is not really designed to do that. If you put things in branches, then you would think that you can do things like merge across, but that doesn't really work either because there are fundamental differences between different environments you want to preserve. Like I don't want my dev database to be merged through to production because that would then mean that production traffic is being served from a dev database. That's not a good idea. So the concept is great, but the execution is often something that companies start having trouble with. And we've seen a lot of companies enthusiastically adopt GitOps and be very successful initially. But then as they do things like try and expand the number of environments they have, or they start onboarding multiple applications, that they start having complexity in actually running the process of managing their configuration in something like a GitOps setup.
Right.
The other problem is the actual deployment is happening somewhere else and it's very hard to troubleshoot and debug, which is why a lot of people have this feeling that even though I've committed this commit to a Kubernetes cluster, it's done a different thing than I was expecting, and it will do a different thing than I'm expecting the next time. Yeah,
no, that's really interesting. And we also had a longer conversation with the CTO at GitHub, who is one of our investors. And so we naturally have a lot of touch points with him. And he himself said that like Git is probably not the best way. And GitHub themselves, they're not using that method, but they're actually using a different method. And he also said so on the interview with us that you can find on our blog, recommended read actually on how they built like the structure and the setup that then solved this problem. And they actually called it internal developer platform. That's one of the terms that they coined. What is that, and how does that actually come into play here?
So an internal developer platform takes a step back from just worrying about the physical files required for the configuration management, and actually looks at the developer experience for developers deploying applications across multiple environments. So rather than a developer having to worry about reconciling the differences between configurations between different environments, or remembering which branch to push on in order to get the right effect or the right cluster, that is all abstracted away into a clear interface, be that a UI, be that a CLI, or be that some kind of API that developers can use. So the idea here is that the developer can express their intent, and then the internal developer platform actually figures out what needs to be done in order to achieve that. And the great thing is that the internal developer platform can worry about what it means to have different environments. It can ensure that we have consistency between environments when we want it, and it can introduce guardrails to make sure that you don't do things like point the production system to the dev database, or even worse, the dev system to the production database. So this kind of structure is what you see being developed at larger companies. It also provides a load of additional things. It automates a load of the kind of standard tasks you have, like how do I add a new service to an application, for example. That becomes something which is not something that you have to go and read a lot of documentation about, but often a single action that you can apply. It also has the advantage of taking away a lot of the complexity of dealing with Kubernetes manifests themselves, by looking at the standards you see across, say, 95% of applications in an organization.
Right.
So developers instead can say, hey, I just want a new service, give me a new service, great. It needs to talk to this database, great. The platform figures it out. Oh, and can you deploy this to this environment for me? No problem, off you go.
Yep.
So that is a great developer experience. And that is where you'll look at the likes of Airbnb, look at the likes of Zalando. They've built these things in-house, in GitHub as well.
Yeah, and if you don't, so that's the general on what an IDP is. But like if we zoom in into the way an IDP deals with application configuration management, the interesting element what I found so helpful is that now you don't take an unstructured script and then figure out whether the deployment runs, hopefully, but you develop against baseline templates, baseline configuration templates, and you apply changes to those templates. And I want to get back to this in a second in an architectural diagram on how this is actually done. But before we do this, let's briefly look at different setups and how those setups affect the personas involved in your team. I'll take that over really quickly, and then you can guide through those different architecture diagrams. We think about 3 different core personas. So one is the infrastructure operator. That's the person dealing with actually spinning up the cluster, maintaining it, all of those things. Then you have the application operator. Now the application operator deals with applying changes to the application configuration. And then you have the application developer, the person that is actually developing the application. Now, in some teams, those are like 2 of those roles might fall into one person, but we often see that this is actually differentiated. Let's look at the representation of the tools and evolutionary steps you just showed us and see how they actually map to the persona. And I think that way we can also describe how this new approach of configuration management actually works.
Yeah, so if we cast our mind back to the kubectl example, this can be described as a kind of change by change setup. So effectively, what you have here is you have the application developer says, hey, I need a new environment variable to define this thing. I'll add that to the code. You have the application operator who's saying, I need to deploy this to a new environment. I need to tweak this environment variable. They both make changes. You run it through some kind of pipeline, and you get a manifest out, and then that is pushed into your cluster, and the changes happen. The infrastructure operator, who is managing the cluster itself and the things like databases around it, is kind of separate. So there has to be some out-of-band communication to say, hey, by the way, can you set up that database? Can you tweak this change? And you hope that by the time those 2 things converge together, then your application will be running correctly. If there's a sync difference, then either you can't deploy your application or deployment fails, or you get some other weird edge case, or hopefully the infrastructure person's got there first so that by the time you deploy, everything's up and running. So that's the kind of change by change nature. And it involves a lot of chatting between team members, which is great if you're a small team. So if you're 3 people, hey, actually, this might be the great way, especially if you're not all in a remote setup, especially in the olden days when we were all sitting in offices and could chat to each other. This might work very well.
Right, and then let's look at the next one where we're already introducing this versioning bit.
Yeah, so as we introduce the kind of versioning, this is maybe introducing Helm and then starting to version these Helm values files especially, and maybe even the charts themselves over time. What we start to see here is the application dependencies are kind of separated out from the main pipeline. So for example, an application developer says, hey, I need this new environment variable to manage this feature of my application. They put it in there. And then the application operator says, yep, I need to describe this in my chart. So I'll introduce a new value, which can be tweaked. And then you have a situation where the application developer can just ship the same code every time. They don't have to worry about where the code is going to be deployed. And it's up to the application operator to make those changes and say, well, this needs to work in dev. Oh, these are the configuration options I need to have for my database or whatever, and it's kind of the application operator that ends up doing the chats to the infrastructure person to make sure that the right infrastructure is available when the deployment happens in the right environment.
All right, and now into the next decade, how do these internal developer platforms solve this next step of evolution in application configuration management?
So the thing that many people might have noticed is that the application operator person is kind of, in both of the two previous bits, the kind of middleman who is shuttling information between the infrastructure person and the developer, making sure that everything is synced up. What the internal developer platform does is basically take that out and instead allow people to talk via standardized interfaces. So we talked about there being like a standardized interface, like an API or a CLI or a UI to allow things to be defined. So what you have is you have your model inside the internal developer platform about what an application is, and the infrastructure operator can then feed in information about infrastructure, being like, oh, if you need a database, this is how you define a database. Or if you need a cluster and you need it for a non-production environment, use this cluster. If you need a production cluster, then use this cluster. And so it becomes kind of very declarative. On the other hand, the application developer says, well, here is how my application works. These are the dependencies it has. And then the internal developer platform basically joins this together to say, okay, if I need to deploy to this environment, then it means I need this bit of infrastructure. I can look up, based on what the infrastructure operator has said, how to provision it or where to find it, and then generate the resulting manifests to actually go and do the deployment into the cluster as necessary, or potentially even set up infrastructure on demand as needed. So in this particular case, it removes a lot of the work that application operator needed to do to join the world of infrastructure and application developer together.
Cool, yeah. And I think that's actually something that more and more teams are either building themselves internally or they take off-the-shelf frameworks to do so. And this core idea of developing against one baseline template makes so much sense, because most Helm charts that we see, right, and we see a lot of Helm charts, 99 point something are all the same, right? And so the little changes between them are sometimes even artificial, because as you said, YAML as a format offers so many ways to actually express the same end result. And so that's why standardizing and not giving everyone all the choice of tweaking every last value in the values YAML file, that makes a lot of sense. So I really believe that this is an approach, a methodology that we will see a lot more in the future. Although if you look at KubeCon, the last conversations, if you look at everything that ThoughtWorks had just put on the radar, that it really looks like this is where the industry is going. So yeah, extremely interesting. Now, for the audience, how do you determine what of those approaches, which methodology is actually the right horse for the right cause? Is there a rule of thumb that you can apply?
Yeah, I think it's tied to maturity and team size. So basically, if you're in early days, then lowest barrier to entry, kubectl is your friend, and that'll allow you to get started straight away. It allows you to do proof of concepts. It allows you to learn about things. It allows you to understand all the details. It's not a sustainable model. Very quickly, you'll get bored of building full YAMLs yourself and trying to keep them in sync across multiple things. So pretty soon, as long as you're building something that actually is going to production, you're probably wanting to be using a framework of some sort, like a Helm or a Customize, in order to manage the kind of repetitive parts. And in addition, you're going to be wanting to make sure you have everything versioned so you can do things like roll back to a previous good version. As teams get bigger, and more importantly, as the application complexity gets bigger, then you want to start trying to abstract out the things that really are the same and things that you actually want to enforce to be the same, because standardization makes things much easier for all the developers involved. It means you have a standard language to communicate your ideas. And it also means that if you bring someone new in, then they only have to learn one way of doing things rather than 15 different ways of doing things. So, and we usually see that starting to become a reasonable point of view at about 15 plus developers building effectively 2 or more applications, application being a loose term referring to a connected set of services. So an application might have a few services in it. There might be like 3 applications which have like between the 24 services, whatever. So at that level of complexity is where people start looking at the world of internal developer platforms. And they may not call it an internal developer platform to start off with. They might start off with a load of scripts that automate a load of chunks of things or generate some initial boilerplate that is then used by a team. That is the start. Those are the seeds of an internal developer platform being built in your organization.
Yeah, beware of the beginnings. Thank you very much. We are slightly over the scheduled time. And I'm like happy to take more questions. Let's look at the first ones that we have been rolling in. Like one is, where do you store configs and secrets for an app which is running in many clusters? Now, if you tie that to what we've just heard, how would you respond to that?
Yeah, so I think one of the key things when you're dealing with secrets management is that secrets are special because they're secret, but in the same way, they're not special in terms of configuration. So if you are centralizing your configuration, you'll be centralizing your secrets and so on. So they should kind of live together because it's just a special type of configuration in general. Now, if you are mature enough to be looking in the world of internal developer platform, then actually the answer is very simple. Wherever your internal developer platform is storing its configuration, its specialization for each service that is, then that's the same place that you should be storing your secrets. So that's kind of straightforward. If you're further down the line, then you have a few options. Generally, you want to avoid having an entirely different conceptual system for secrets management, because then that join together of making sure that your secrets, the right secrets in the right place for the right deployment, becomes really hard. So you want something that can, as much as possible, mirror your structure, and that kind of depends on your setup. If you're using a single cloud provider, maybe using their managed secret store, the various types that exist out there, might be a good solution. There are other solutions. Generally, probably avoid self-hosting any of this yourself, because that is definitely going to make it difficult to join things together at the end. So those are the kind of strategies I would take. But there is no perfect solution. There isn't a golden solution out there. You have to tune it to your particular circumstance.
Mm-hmm. That makes sense. Another question is how to maintain standardized and reuse structured app configs for Kubernetes deployments. We talked about that and how to apply that to different methods, but the question goes on, how to keep transparency of current deployed configs and support troubleshooting, and especially which level of documentation is required to avoid a single point of failure. And we learned that if you have an internal developer platform that's sort of being taken care of, but in the steps beforehand, how does that pan out? So
I think it depends on the level of complexity. So again, if you're at that stage where you've just switched from kubectl to using version Helm charts, then I think it's up to you at that point to make sure that you put in place the standards and the approach. A lot of that's going to be very manual because the tooling is not going to help you. So you need to make sure that all of your developers understand the effect of, say, changing a template, make sure that that change is communicated widely and you actually have a good understanding of what's going on. As the number of developers increases and the number of services increase, that becomes increasingly problematic. And what we see is that divergence. So different services will end up with slight tweaks, and slowly over time, they will look remarkably different from each other. And that is then the problem. There's a documentation nightmare because you either are documenting each service on its own, or you have centralized documentation which doesn't apply to any of the services you have. So I would say that if you're struggling in that space where you have this divergence, then that's probably the indication that actually you should move to some kind of internal development platform, be that either homegrown or an off-the-shelf one that you can find. Then those kind of pieces will resolve themselves, because the internal development platform does the enforcement, which means that your documentation makes sense because it's the same for everything. What you often find, especially with development teams, is once there is a constraint, then the constraint, it makes sense and is well enforced, then it becomes easier to adopt it and people stop complaining. So a classic example of this is putting linters in CI pipelines and putting things like a style guide checker into code. Initially, people complain when they have to change everything, but over time, people just adopt to the style guidelines and adopt to what the linter says because it's easier than complaining. And then overall, that means a massive increase in quality. And you can look at internal development platforms doing the same thing, but for your application configuration.
Right. There's one, we have time for one more question. And that's around what level of knowledge does a development team actually have to have in all of those different methodologies? So how does that map? How do you make sure that, like how much Kubernetes specific and application configuration specific pieces of knowledge does the development team actually have to learn, or should, or is it, how do you think about those things?
So I say as the complexity grows, as the maturity increases, what we tend to see is a change from generalists, who are generally in the small teams, through to specialists who are in the larger teams. And by specialists, we mean like you have hired data engineers, you have hired specific front-end engineers who are proficient in a particular technology, you have found your, I don't know, AI engineers, whatever. So these are people that have very deep specialism, and they are less likely to want to get stuck into the details of Kubernetes, mainly because it's a whole new thing they have to learn and they've already specialized. At the start, especially in a team that's bootstrapping something, generally everyone is doing everything from setting up infrastructure to writing the code to troubleshooting to making the coffee, whatever it is. Everyone is jumping in and doing the same thing. So what we tend to see naturally is as organizations get bigger and more complicated, the average level of something like Kubernetes knowledge goes down.
Right.
And so as you get to those side of things, you really want to have a system where developers review Kubernetes in implementation detail, not something they have to care about, something that's there. And if they hit an edge case that involves having to talk to Kubernetes or understand Kubernetes, they can do that. But day-to-day, they don't have to worry about it. So that's one of the things as you get towards internal development platform. And even when you start getting into the kind of Helm chart system, you're trying to abstract away a lot of that complexity so that people can focus on writing their code and deploying their code that they've written rather than figuring out how to run Kubernetes. So there's a nice correlation between kind of maturity and average Kubernetes knowledge.
Okay, that makes sense. Thank you so much. And I think with this, we're closing this session. There's one question that's probably not entirely fitting this here, and that's the question around applying different resource limits to the same app in different environments. We have a couple of great webinars coming up on this, actually on Thursday, deployment automation with internal developer platforms. On the GitOps debate, we have a community conversation. Thank you, Jonathan. We have a community conversation on the GitOps bad and ugly, together with Adam Sander from Container Solutions, the guy who wrote the article GitOps, the bad and ugly, recommended. And then we are having a conversation. I'm actually having a conversation with Fusin Verhan from Wayfair and Yair Tzioni from Polar Squad on standard versus freedom in the DevOps world. How should you think about restricting freedom, standard operating procedures, which is a very, very hot topic. You can make a lot of mistakes, and we are going to have that conversation in 1 or 2 weeks. I don't really recall, but we'll send along the information. So you're all invited to those conversations. Thank you so much for the engaged discussions. Thank you so much for sticking around and your interest in this. Thank you so much, Chris, for presenting. And we wish all of you a wonderful evening and enjoy the rest of your day.
Yep, have a great day, everyone.
Bye.